Howdy guys, welcome to another stats video. Today we're going to talk about confidence intervals for means. So far we've only talked about confidence intervals for proportions, all the p-hat business. So to estimate the true mean of a population from the sample mean, we use a one sample t interval. Why t and not z? To use z, we need the standard deviation for the population. Now, most of the time we don't have that. Okay. So, write a few observations about the difference between the t distribution and the z distribution. We're going to look at this together in class, but what you can do if you miss is look at that t versus z Desmos graph and see what you notice. Okay. I think you'll find the following: the t distribution changes based on degrees of freedom. And degrees of freedom is a sample size minus 1. As these degrees of freedom increases, the t distribution becomes very close to z. The t distribution is shorter in the middle and has bigger tails. So that's kind of pictorially how they match up. How would degrees of freedom increase? Well, that would be the sample size increasing. So as the sample size and degrees of freedom get bigger, we get closer to a z or a normal distribution. So we have conditions for one sample t intervals. There are 3 of them, and one has 2 ors. So the first one is either the parent population is normally distributed, or the sample size is more than 30, or the sample data is roughly symmetric with no serious outliers. So to check this roughly symmetric piece, we're going to use easy calculation. This is one of your bookmarks for today. We would use the calculator, but we don't have that option. .com/graphs/create-histogram. .php. I don't know what that means. Okay, so I'm going to show you how that works. How we're going to create a histogram with this thing. Yeah. So if we need to check, if we don't know the parent population is normal and we don't know that we know that the sample size isn't more than 30, we're going to need to graph this data and using a histogram and just see, is it roughly symmetric, okay, where there aren't any major outliers. Okay, the second condition is that we're dealing with a random sample or a randomized experiment. The third is that the observations are independent, or that the sample is less than 10% of the population. So if they aren't independent, we've got to make sure that the sample size is less than 10% of the pop. Okay. First example, a new formula for the propellant of missiles is being tested to determine if it is superior to the current formula. From past experience, the mean distance traveled has been 340 miles. 12 missiles with a new propellant are fired into the Pacific Ocean and their distance is measured. The data is given below. Support your conclusion with appropriate statistical evidence. Now, it doesn't tell us what percentage we want our confidence level to be at. So we're going to have to make a decision. Typically, it's either 90, 95, or 99. So before we even get cracking, we're going to do conditions. We're going to say this is a one sample T interval, first and foremost. Okay. We're going to assume randomized experiment. The missiles are independent of each other. So this is the second, this is the third condition from above. And then we're going to graph to check for symmetry. We're going to find that the histogram, I want to show you how I know this stuff. The histogram was roughly symmetric with no outliers. Okay, so let me show you how to do that real quick. Okay, so it won't let you actually create this without creating a title and stuff for it. It doesn't have to be anything fancy. We're going to call this missile travel distance. That's what the graph is going to be. And then it wants units down here. This is going to be in miles. This is how far they traveled in miles. And then we're going to enter these values. You are going to use commas to separate, no spaces. So 375, 376, 304, 345, 368, 329, 372, 347, 342, 391, 400, and 325. Okay, enter the number of groups. Well, it says enter no of group. I think that means enter number of groups. So remember what a histogram looks like. It looks like a box plot, right? So these guys are going to be lumped together in X number of groups, however many groups we decide. And I've already looked at this one, and I think 4 works out pretty well. What you can do, there's a general rule of thumb. You want to be somewhere around the square root of n, the sample size. So there are 2, 4, 6, 8, 10. There are 12 of these guys. I think there are 12. Let's double check. There are 12. And the square root of 12 is between 3 and 4. So 3 or 4 would probably be our ideals, but you don't have to calculate. For whatever reason, it just automatically does it for you. You don't have to hit the calculate. Maybe you can hit the calculate button. Let's just see what that does. Yeah, it doesn't change anything. So, roughly symmetric. Seemingly no outliers. Kind of cool, right? Your graphing calculator will do this too. It doesn't do as nice of a job of it, actually. This is really kind of a cool graph. It took me a minute to find one that would work, that looked okay. So that's how we create a histogram if we need to. Remember, we're just doing conditions right now. Okay, so we've got our conditions. We said the histogram was roughly symmetric with no outliers, so all of our conditions are met. Now we need to know the sample size, and I'm using the letters and abbreviations from our bookmark that's going to help us figure out what our t-interval is. So this is 12, our mean is 356.167, and our standard deviation is 28.784. I'm going to show you how to find these guys. So we're going to use Desmos, and we're going to do mean. The notation for mean is mean of x sub 1. And for standard deviation, it's STDEV of x sub 1. I'm going to show you how to do that real quick. Okay, so first you're going to hit this plus table, and we're going to enter in these values. Again, it's a pain. You can hit enter and it'll take you to the next line. Don't worry about the y's, we only want the x's here. Okay, I think that's it. That's 2, 4, 6, 8, 10, 11, 12. Perfect. Okay, next line down, we're going to type in those things for mean. We're going to do the mean of x underscore 1. That'll give you a subscript, and it'll tell you what the mean is, the average. We can do standard deviation, that's the abbreviation for it, of x underscore 1. And there's the standard deviation, the sample standard deviation. So that's where those values came from, the mean and the standard deviation. Okay, finally I'm going to be able to take this value, these values, excuse me, and we're going to come up with our t-interval. It's going to give us 337.88, comma, 374.46. Now where does this come from? It's the other bookmark site. sample-size.net/confidence-interval-mean. Give me a second, I'll show you how to do that. Okay, so this is the website that's bookmarked under today. Our mean, it won't take all these values, but I'm going to enter them in anyway. 256.167. Well, yeah, it'll only go to 3 decimal places is the deal. Standard deviation, sample standard deviation we found from Desmos was 28.784 to 3 decimal places. And then we're going to use 95% confidence level because they didn't say what to use. So I'm going to hit calculate. Then I'm going to go down here, and unlike intervals, we don't have multiple to look at. There's just one t-interval. Okay? So you can see that n-1 is that degrees of freedom thing. And then this t for t, and there's a bunch of other stuff that you don't really need to worry about, but we're looking at this as our lower bound and this is our upper bound. Okay, so we're going to say we are 95% confident that the true mean distance is between 337.88 miles and 374.46. miles.